David Smith here with another Flip Classroom video. 3 tips before we start. First, remember you can pause the video anytime to catch up with your notes. Second, you can turn on the captions below so you can watch my words go by on the screen. And lastly, you can play the video at double speed if that helps you get through it faster. Today's lesson covers using probability tree diagrams to represent situations and to calculate probabilities. So these are powerful tools. They're also a little bit complicated to master, but I strongly recommend that you do so because they are so powerful. Okay, so let's take a look at an example. Mark buys suits from 2 clothing suppliers, number 1 and number 2. He only buys blue and gray suits. So, okay, maybe not super imaginative, but it will suffice for our situation. So prompt 1, represent this situation with a probability tree diagram. Now, if you already know how to make one, I would say pause the video right now and do that. Otherwise, since this is a video introducing tree diagrams, I'm just gonna go ahead and do it. Okay, so you analyze the situation as though you were this person. So what's your first choice? You have to figure out who you buy your suit from. So you're gonna make a branch. That's why it's called tree diagram. So this would be number 1, that's supplier number 1, and this is supplier number 2. Now, what's your second choice? It's blue or gray. So now we're gonna do blue or gray, and then we're gonna do blue or gray. So there's actually 4 different outcomes for the situation. There's 2 outcomes, blue or gray, for supplier 1, and there's 2 outcomes, blue or gray, for supplier 2. So that is a probability tree diagram for our situation. Now, maybe you want to label it a little bit more fully. Maybe you'd want to say clothing manufacturers or suppliers 1 and 2, and then spell out the colors, but essentially that's what we've got. Okay, so now we're going to give you some information, and you're going to use that to flesh out all the probabilities for the tree, because we have 1, 2, 3, 4, 5, 6 different probabilities that we can put on this tree. So here's our data, known probabilities. 73% of all purchases are from supplier 1, so we know that. 16% of the supplier 1 suits are gray, so we know that. Finally, we know that 80% of supplier 2 suits are also gray. So why don't you pause the video and put that information on your diagram. Put it right by the branch that you think it goes with. So pause the video, do that, and come back. Okay, let's see how you did. So 73% is 0.73, because we're going to end up doing some multiplication and some other numerical operations. So we need to convert these into actual numbers that we can use. So 0.73 is the probability that he's buying from supplier 1. 0.16 is this one. That's the probability, or that's the percentage of suits that are gray from supplier 1. So I put it by this branch. And then the last one was 80% of supplier 2 suits are gray. So that's 0.8 goes there. Now you have everything you need to finish. There's 3 branches that aren't labeled. So pause the video and go do that. Okay, so what I did is I exploited the fact that between supplier 1 and 2, there's 100%. He's buying his suits from 1 or 2. So if this is 0.73, this has to be 0.27 because these add to 1. Same thing here. If that's 0.16, that has to be 0.84. And if that's 0.80, this has to be 0.20. Now, of course, we're going to do some calculations here. So here's your first one. What's the probability that the suit he bought is gray? So use the probabilities here to figure that out. Okay, let's see how you did. So the way you do this one is there's 2 outcomes, 2 separate outcomes that work. So we've got the one pathway, supplier 1, gray suit. That's this, 0.73 times 0.16. The other outcome is supplier 2, gray suit. So that's 0.27 times 0.80. Now we add these 2 probabilities up to get our total probability. I get 0.3328, which is 33.28% chance that he buys a gray suit. Okay, this one's a little bit more complex. The second probability I want you to calculate is what is the probability that he bought from supplier 2 given that he bought a gray suit. Now this is where one of the rules from our last lesson comes into play, and it's not immediately obvious that you need to use this rule. So I want you to pause the video, look back through your notes, and see if you can come up with the general statement of what we need to do next to figure out what that probability is. Okay, if you remember from the rules we had before, when you have the probability of something given something else, it is the probability of the intersection of the two on the top divided by the probability of the given that. In this case, gray suit. I'm using G for gray suit. So now, pause the video and do a plug-in step and solve to find that probability. Okay, let's see how you did. So what this is it's the probability of the intersection of supplier 2 and a gray suit. So that's just this branch here. It's supplier 2 and gray suit. So that's this branch, 0.27 times 0.80. We actually did that calculation up here in the last problem. So that's 0.27 times 0.80. That's the top of the fraction. The bottom of the fraction is just the overall probability of G of a gray suit, which we calculated up here. That was 0.3328. So I went ahead and put that on the bottom. I did my math. I got 0.649 or 64.9% chance that he bought it from supplier 2, given that the suit he bought was gray. Okay, here's another probability tree problem. Probability problem. The box contains marbles in 3 different colors, as follows. There's 5 red marbles, 6 blue marbles, and 7 orange marbles, okay? And in this problem, we're gonna take 2. So we're gonna reach into that bag and pull out 2. First prompt, draw a tree diagram. Okay, so pause the video and do just that. Okay, so again, pretty straightforward, but we have 3 choices. We have 3 different colored marbles. So each iteration of pull a marble out is gonna have 3 different outcomes. So here's my first draw, red, blue, orange. And then here's my second draw. I can get another red, blue, orange for each of my first draws. Next prompt, I want you to put your probabilities by your branches, okay? Now, you can see that it starts to get really busy up here. So my recommendation is that you get used to making your first branching on your trees pretty wide, especially if you have like 3 choices for each step. So go ahead, you can write the fractions for the probabilities for each of these, okay? These ones are gonna be a little different. You're gonna have to think about what happened here before you can populate those branches. All right, let's take a look. The bag starts with 18 marbles. So the red branch, there's 5 out of 18 for red, that's that probability. The blue branch is 6 out of 18, and the orange branch is 7 out of 18. That's just straight out of the problem. Now it gets a little tricky when we start doing the second draw, because if we're on this path, we've pulled a red. So the number of marbles left is 17. So the bottoms of these fractions are all the same. And we have 1 less red. So this is 4 out of 17. These 2 are the same as they were before because we pulled a red. They still have 6 blues and 7 oranges all in there still. So those numbers don't change. Now with the blue branch, if we picked a blue, 6 out of 18, that means we still have 5 reds in there, so that's 5, 17. We pulled a blue, so the blues went from 6 to 5, and we still have 7 oranges, so there's 7 out of 17. And the same reason populates these last 3 branches. So that is the full tree with all the probabilities listed on there. Now, this is super helpful because I could ask you a million questions about this situation and you could quickly calculate your probabilities based on that tree. Okay, here it is. What is the probability of drawing 2 different colors? Now we have a lot of different outcomes for 2 draws. We have 3, 6, 9. We have 9 different outcomes. Now, all these odds aren't equally likely, so we just can't count up the 4 that have, or the 6 that have different outcomes, different colors, and say, oh, it's 6 out of 9, because each branch is not equally likely. If it was, then we could do that, but we can't. So what we have to do is we have to calculate the probabilities of getting red, blue, red, orange, and add that to blue, red, blue, orange, and add that to orange, red, orange, blue. And we add up all 6 of those probabilities. That gives us the overall probability of drawing 2 different colors. I'll get you started on the first 2, and then I want you to finish the rest. So watch this. What is the probability of getting red blue? It's going to be 5/18 times 6 over 17. So 5 over 18 times 6 over 17. Go ahead and pause the video and do that calc. All right, so we just multiply the fractions across. Tops times tops, 30. 18 times 17 gives you 306. In fact, the bottoms of all of these fractions are going to be 18 times 17. So that's going to be the same. So why don't you go ahead and pause the video and calculate the probabilities for each branch that gives you 2 different colors. Whew, that's a lot of calculating there. So here we are, we have our 6 probabilities that give us 2 different colors. We've got our red-blue, red-orange, we've got our blue-red, our blue-orange, and then finally we've got our orange-red and our orange-blue. So I put all my fractions in there. I stopped writing over 306 because that's just redundant. They're all over 306. So here's the thing about using probability trees. To get the probability going along a branch, you multiply because that's the intersection. If you're trying to get an overall probability where you've got different outcomes on your tree that give you what you're after, then you add up all those outcomes. So go ahead, pause the video and add up all these outcomes to get the overall probability of getting 2 different colors. Okay, let's see how you did. So check this out. These are all over 306. So I'm just going to add all the tops together over 306. So this is all my tops right there. Put them over 306. So when you add the tops, you get 214 over 306. Now I can pull out the calculator, do my division, 0.6993, which is 69.9% chance of getting 2 different colors. Okay? Now, one last question. There's a quicker way that would entail only calculating half as much. Often in probability problems, that's an option. This is a full points answer, but you can get full points with another way that just requires that you remember one key aspect about any probabilistic situation. Pause the video, think real hard, and come back when you think you know the answer. Okay, here's the answer. All of the probabilities add up to 1. There is a certainty that one of these events is going to happen. So we know that all of these fractions add up to 1. So the way to save you some calculating is just do the 2 colors the same. So you do red, red, blue, blue, and orange, orange. That's half as many calculations as we did. We did 6 probabilities. You'd only have to do 3. Find that probability, that decimal, and then subtract it from 1. And that would give you the remainder, which would be probability of 2 different colors. So there's a lot of situations where you can do that and save yourself some trouble. I forget how I start that. Does it go?
Here, I hope the video was helpful. I can put it.
Now that you've watched the video, write down any questions you still have so you can remember to ask them in class next time we meet. Also know that you can watch the video again if you want to deepen your understanding or patch up any gaps. Finally, give me a like and subscribe if you enjoyed it.
Yeah!